Yeah, so I'm going to talk about asynchronous programming, and usually I always give the same talk because what I really don't like is inversion of control, right? And those who know me, they know exactly sort of what I'm going to talk about, but I tend to talk about different systems, right? And today I'm actually really excited because I get to talk about a system that I think that I'm convinced is going to work really well. So that's pretty satisfying, and that's kind of, if you build a concurrent framework or library, then most of them, they don't quite work always or have their issues, but this time around I think we got a really nice set of constructs here. And well, that's also mostly because we were inspired a lot by existing systems that did a lot of things right. So we didn't have to do that much work, but it's still quite interesting what we did, I hope. And so yeah, well, so about myself, I've been working on concurrency libraries and frameworks for Scala since 2006. And I started actually by writing the first actors library for Scala, but then I did a few other things. I worked a bit on type systems for isolating processes. Then I went to Stanford for a postdoc to work on embedded DSLs, parallel DSLs, things like this. And so now I'm sort of back at TypeSafe, where we're really interested in building things that work really well in practice. So that's what I'm going to talk about. And yeah, to start, I wanted to make sure you all know about Scala Days. It's going to be in NYC in June. So if you have the chance, please come. So what's the problem? Well, the problem is asynchronous code, and typically you have the situation where you program against an API that requires you to register callbacks, so that you get notified whenever some event happens or a read operation or a request comes back, right? And well, whenever you do that, you're essentially writing asynchronous code, and you can be prepared that with your system evolving, it's gonna be quite complicated usually. So it simply doesn't scale to large programs, right? And that's what people refer to as the callback hell, right? Which is where essentially people are still really excited, of course, about Node.js and these approaches, but the question is how can we make that scale? Things are efficient, but it's more about how can you maintain that sort of code. And but of course there's no way around it, right? If you want to build a scalable concurrent system, it has to be non-blocking and has to be what we call reactive at TypeSafe, right? You need a reactive architecture essentially. And of course there have been a bunch of approaches so far, and some of the things that I think work really well is what Don Syme did in F# with the asynchronous workflows, and similarly, although a bit different, in C#5 with async and await. And this time around for Scala, we didn't try to break off the next revolution, but to actually say, well, C#5, the model of C#5 is actually quite nice, right? I think they did a really good job. And so the question is, can we provide something like that in Scala, but in a way where we don't have to extend the language so much, right? And in fact, what I'm going to present to you is not a language extension. Even though it does require a fair amount of compiler hacking, as we're going to find out. But it's not a language extension. So that's that's positive because, well, rather than, many people think that Scala is already sort of big, even though if you compare it to Java or C#, it's actually, it's not that big of a language, right? So the roadmap is to introduce a new feature for async programming. And I'm going to start by showing you how you can use that today, right, with futures in Scala. Because we provide sort of an integration with that out of the box. And so you can, pretty easily start working with that. Going to talk a little bit about advanced usages, where people who know a little bit about, delimited continuations, CPS, and things like this, get to see that, certain things you can do with async. You don't really need necessarily the full power of delimited continuations. And after that, I'm going to show you how you can connect our async system to other APIs. So, because the system is actually designed so that it's not only usable with our built-in types, right? You can actually, quite easily connect it to other APIs, right? Even Java APIs that are asynchronous, right? So, so it's not like something where you have to buy